Bravo flight, red land, runway 22, be another inbound, turning into the intersection of north south taxiway left.
Hobby Tower, long easy 316 Delta Bravo, flight at 25 north for landing.
Last year, more than 600 million people flew commercial airlines. Flying remains the safest of any means of transportation available today. However, since 1982 at airports around the country, there have been 23 fatalities and over 300 injuries due to commercial aircraft runway overruns during takeoffs or landings. And every major overrun accident occurred on runway safety areas less than 1,000 feet long. Overruns still occur at a rate of about 10 each year, most during landings in poor weather. Aviation safety remains the single most important concern in the aviation industry. In an effort to reduce or eliminate the runway overrun problem, the FAA requires a 1,000-foot-long safety area at the end of each runway. However, many runways built prior to this standard simply don't have the room, and it's impractical to acquire the additional property needed. Impractical due to high costs and space being limited by accommodating highways, waterways, railroads, terrain, or populated areas. After investigation of numerous runway overruns on short safety areas, the National Transportation Safety Board told the FAA a solution was needed where the 1,000-foot safety area can't be built. A solution was finally provided through a joint effort by the FAA, the Port Authority of New York and New Jersey, the academic community, and ESCO, Engineered Arresting Systems Corporation. ESCO has provided more than 4,000 aircraft arresting systems in use around the world in the last 50 years. It was logical for ESCO to become a member of the team to solve this major airport safety issue. The result is EMAS, Engineered Material Arresting System. The challenge: develop a system to safely stop an overrunning aircraft on runways where obtaining the FAA standard 1,000-foot-long safety area is not practical. EMAS is composed of engineered cellular cement blocks designed to safely stop an aircraft overrunning a runway at 70 knots or less with minimal damage to the aircraft and little risk to passengers. The system is installed on the existing non-standard safety area. EMAS fully satisfies the safety requirements of Part 139. As the aircraft enters the EMAS, it makes a grade transition from the paved ramp into the cellular cement arresting bed. Aircraft wheels then establish a tire-to-material interface, crushing the blocks as it moves through them. It is this contact that creates resistive load, or drag force, that quickly slows and ultimately stops the aircraft. Every system is customized to airport needs and limitations, and further customized to specific aircraft types at a range of runway exit speeds. Each arrestor bed design uses ESCO's complex computer analysis of 100 variables for each aircraft operating at the airport. Every design is customized and performance is modeled using a computer model validated through FAA testing. On site, the area is prepared for EMAS and individual blocks are set into place. They are adhered to the pavement and sealed to further maintain the integrity of the system. Simple, straightforward, effective. The results are dramatic. Many live tests were conducted demonstrating the effectiveness of the system. An EMAS was constructed as a test bed 325 feet long, 40 feet wide, and a maximum 24 inches deep. Without the use of brakes or reverse thrust, an FAA Boeing 727 overran the runway at 55 knots, 63 miles per hour. The aircraft came to a full stop 260 feet into the arrestor bed. The computer model accurately predicted performance of the final outcome within 16 feet. Testing has also demonstrated EMAS meets all the stringent requirements for an arresting system. From extreme thermal cycling for fire and rescue maneuverability to withstand jet blast and the ability to withstand a fuel spill fire. EMAS is now an AIP-eligible FAA standard. FAA followed the advisory circular with a policy order that defined EMAS as an option to meet RSA standards. EMAS is an FAA-accepted solution to short runway safety areas. In March of 2004, the FAA issued a dramatic policy change providing new guidance for upgrading runway safety areas to meet Part 139 requirements. EMAS has demonstrated to be equivalent to a standard 1,000-foot-long runway safety area in stopping an overrun. In fact, during inclement weather such as conditions of rain, snow, or ice, it is superior to a turf safety area. Therefore, it makes sense to select the least expensive runway safety area upgrade solution, EMAS, or Standard Safety Area. And that is exactly the basis of the new FAA policy. In the past, obtaining a 1,000-foot-long runway safety area was the FAA's first choice, regardless of the cost. The new FAA policy places a dollar limit on the cost of upgrading safety areas. This limit is 3 times the cost of a standard EMAS, based on the critical aircraft using the runway, and is generally in the $9 to $12 million range. The cost limit applies to upgrading the safety areas on both ends of one runway. Life cycle costs are then computed for both an EMAS and a standard runway safety area, and the least expensive solution is selected. Order 5200.9 contains guidelines on how to compute these costs. 2 other dramatic changes are now part of FAA runway safety area policy. The first change permits a 600-foot-long safety area instead of 1,000 feet if an EMAS is installed on the safety area for overruns. The second major change permits reducing an existing 1,000-foot safety area to 600 feet with an EMAS. The unused safety area can now be part of a runway extension. By reducing the safety area on each end of the runway to 600 with an EMAS, a total of 800 feet is available for a runway extension, all on existing airport property, avoiding both cost and environmental issues. For a new runway, only a 600-foot safety area with EMAS is needed, again saving both costs and reducing environmental impacts. The new FAA safety area policy permits increased flexibility in selecting a safety area solution. The bottom line is the enhancement of airport safety with major cost savings to airports and the FAA Airport Improvement Program. Over the coming years, these cost savings will be used for other important airport programs. EMAS, as designed and manufactured by ESCO. In 1984, an SAS DC-10 overran the runway and came to rest in a nearby drainage basin. There were 15 passenger injuries and over $20 million in aircraft damage. On May 8, 1999, the EMAS was put to the test in a real-life emergency situation when a Saab 340 overran runway 4 right at a speed of more than 70 knots. The EMAS performed as designed and stopped the aircraft quickly and safely. There were no passenger injuries and only minimal aircraft damage. EMAS was once again put to the test in May of 2003 when an MD-11 cargo plane overran the same runway. The airplane was stopped in the EMAS arrestor bed as predicted by our computer model and with no injuries to the crew or damage to the airplane. This time, with EMAS, everybody walked away.